So again, good evening everyone. How are you guys? Fine? Sagala boom boom? Yes or no? It is. Guys, are you able to hear me? Okay. सब यहीं पे हो? Yasmin, Hitesh. Okay, Sneha has came. Okay. So let us start. So we are going to start. So till now, a little bit of digression of previous what we did. We did relative velocity concept. Okay, means relative motion. We tried using this reference from this reference point of view frame. Okay, and according to that, we are going to discuss some of the basic problems like river and boat swimmer problem and some like rain and man concept and projectile motion also. Little bit this kind of problems we are going to do. Okay. So before going to that, first we'll try to complete this particular part. Okay. So let us take an example. Okay. First, I'll take one example for you guys. So have you seen river or not? Have you seen swimming in the river or not? Or have you seen the boat crossing the river? Everyone, have you ever been in the steamer or not? Yes, Wayne? Yes or no? Okay. So what happens? Like let's suppose this is my river water. Okay. This is my river which is flowing along this direction. Okay. So this is river which is flowing towards east direction. It has velocity v. Okay, I'm representing v of r as velocity of river. Okay. Now, when you try to cross it, have you like let's suppose if the particle starts to swim from here and it want to go to this opposite bank. Okay, means what happens? A person is there who started. So let's suppose here is my Hitesh. Okay, our best swimmer. Hitesh, do you know swimming or not? Tell me yes or no. Hey Hitesh, do you know swimming? Little bit. When you will go, like when I will go for trekking and all, then how come you will go over there, huh? So let's suppose Hitesh know little bit of swimming. Okay, and he's trying to swim over here. Means he's trying to swim in such a way that let's suppose this initial point is A and he wants to end up at the point B. Like he wants to end up on this particular corner. Okay. Now how he can do? Tell me one thing. Let's suppose if the person starts to swim due to the river flow, what will happen? This person will start to go towards this side or not? Tell me yes or no. There will be a little bit shift in the person or not? Or yes or no? Everyone. Yes. So what is going to happen? Let's suppose if this person is here who is trying to go from point A to point B directly to the opposite bank, what is going to happen? That this person will start shifting towards the right side due to the river flow. Okay. Got it or not? But as we know that what is going to happen that we want to end up at this point B. So how to move over here? The person will select some kind of direction of like the person will sometimes select this kind of movement or not. He will try to swim in this particular direction. What he will try to swim in this particular direction, and due to the river flow, what will happen? He will follow this kind of trajectory. Yes or no? He will follow some kind of projectile kind of trajectory, and he will try to end up over here. Are you able to get me or not? So actually, this is the real practical case. Okay, means this is what is going to happen. Okay, like whenever the person starts to swim inside the river to go on the opposite bank, he can't reach over here directly due to the river flow. River will try to make him flow towards itself. Okay, then he needs to go to the opposite side, means he needs to swim across the opposite side of the river flow so as to reach at the opposite bank. Got it or not? Now, you try to observe over here, this person is making some kind of angle theta with the particular vertical like or with the particular width of the river or not. Tell me yes or no. So we need to do all these. The problem is like in the question what it will be asked that how much angle, like with how much angle this person should swim so as to cross this particular river over here. Got it or not? To know about this, we are going to utilize different concepts and different theorems so as to talk about this. Okay. So now look over here. This whole thing, this whole practical case, I will try to do according to this particular way. Okay, means with this frame of references. Okay. So let us see over here. See this. So again, you have try to understand. Okay. Have you watched the videos or not, everyone?
Yes, sir.
Oh, good. Yes, sir. Then okay. Then little bit you can handle this. Okay. Now look over here. See this. What has happened? So now tell me one thing. Everyone, see this. This river, on this river, you try to see, this river velocity is determined by some kind of tree or a person standing on this bank of the river or not. Tell me yes or no. So actually we are trying to understand, see this. Is this an example like we have an observer on the ground, then we have a particular observer which is moving. In this observer, there is a person who is trying to swim and trying to go to the opposite bank. So this is like this kind of case only, where what used to happen, you we have on one fixed observer, and we are calling this fixed observer as what? Ground. Okay, we are denoting it by G. Okay, this reference point I am denoting it by G. It has x-axis and it has y-axis. The person is traveling in the river, means try to understand, there is a swimmer. Okay, yes, hello sir, hello, hello, who is this? Huh, okay, yeah, yeah, yes sir. Okay, so in WhatsApp I think I have forwarded you the link, sir. Okay, okay. On this number only I need to submit, share the link now. Oh, sir, Yunus Ahmad. No, 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 no. Second Q, first Q science. Okay, okay, okay. O- Okay, 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 okay. Got it, got it. Okay. Arey Baba, what is happening here? I have saved the wrong numbers. Hey, Yasmin. Hey, Hitesh, tell Ahmad yesterday tomorrow, like to share the number, okay? I am calling someone and it's getting called to commerce guys. Okay, now look over here. See this. What has happened? A person is there who is swimming inside the river. Okay, so I am considering this person to be over here, or I'm considering this to be like I'm considering this as a boat. Okay, so I have taken it as to be boat. Now we have over here as a river. This is my river. Okay, I'm denoting this reference point or this fixed point of the river as name R. Got it or not? It is moving with some velocity towards east, and that is denoted by velocity of the river R. Got it or not? Everyone? This is Y prime. This is X prime. Are you able to get me or not? Everyone? Yes or no? Arey, I can't hear a little bit say some guys yes or no. Okay, so that I can be a little bit motivated. Radha, Sujit, Hitesh, got it? Ankit, here only. Afan, here. Nisant, here. Yes or no? Now look over here. You try to see a little bit. I'll try to improvise this so that I can draw the diagrams perfectly. Okay. So boat is over here. Okay. So boat is over here. Okay. Now look over here. See this. Boat is moving in the river or not? So this particular line will denote the it is going to show what velocity of boat with respect to river. Now river is also moving with some velocity with respect to ground or not? Tell me yes or no. River is also moving with some velocity with respect to ground. That means what? With respect to the ground, boat will have different velocity or not? So I'll attach over here and I will get the velocity of boat. So now look over here. This is what? This is velocity of river with respect to ground. This is velocity of boat. This is representing velocity of boat inside the river, and this is the velocity of boat with respect to the ground. So I'm writing it over here. What I'm going to get, we know that like position vector of river with respect to ground plus position vector of boat with respect to river is going to be equal to what? Position vector of boat with respect to ground. Are you able to get me or not? Now, if we write in terms of velocity, what kind of equation I will get? Velocity of boat with respect to ground is going to be equal to how much? It is going to be equal to velocity of boat with respect to river plus velocity of a river with respect to ground. Now we know that ground is stationary or not. Ground always remains at zero velocity. Yes or no? So what is going to happen? That we can write this as, since g is zero, so velocity of boat is going to be equal to velocity of boat in the river plus velocity of river. Are you able to get me or not? So this is the whole relative velocity equation for a boat which is moving inside the river. Are you able to get me or not? Or yes or no? Everyone? Afan?
Yes,
Hitesh?
sir.
Radha? Ankit? Are you able to get me or not? Okay. Now the point is like this, right? See, why I told. See, if the boat starts to move with its original velocity, what is going to happen? It is never going to cross over here. It will end up over here. Why it is going to end up over here? Because the river is trying to make it pull towards itself. So the boat needs to have some kind of another velocity in this particular angle theta, and I denote this as velocity of boat with respect to river. Now, river is flowing along this way, so I can denote wait, I can denote the velocity of river, sorry, along this side, yes or no? This is going to be what? Velocity of a river. Are you able to get me? This is velocity of a river. Okay. Now, what is happened? Boat is moving towards this side with making angle some theta with the vertical. Okay. And it has velocity of boat with respect to river. But since this boat has its own engine, therefore what is going to happen? This boat will have its own velocity which is going to be with respect to the ground. Are you able to get me or not? And that is what we are calculating. Like what will be the original velocity of boat if it tries to move inside a river which is moving towards east. Okay. Now look over here. We are trying to define the parameters. What are the parameters? The width of the river is given as W. This is what? The width of the river. Okay, got it or not? So all the parameters are given. Width of the river. This is velocity of boat with respect to the river. This is velocity of the river. The particular boat needs to have the original velocity as how much velocity of boat in the river plus velocity of the river. Are you able to get me or not? Or yes or no? Yes or no? Now look over here. This equation, utilizing this equation, we are trying to devise something. Okay. Now what we are trying to devise? Look over here. 6. So first case. Now, you try to understand. Okay, I'll just zoom this once again a little bit. You try to understand. See this. This velocity of boat with respect to river will have two components or not. One, velocity of boat with respect to river cos theta along the width of the river, and one velocity of boat with respect to the river in the opposite direction. Velocity of boat with respect to river sine theta in the opposite direction to the velocity of a river. Are you able to get me or not? Are yes or no? Okay. Okay. Now look over here. I'm trying to minimize this. Now look over here. I know therefore since we have two velocity component, one velocity of the boat along the direction of width of the river, one velocity of the boat with respect to river opposite to the direction of river. Okay, so now look over here. Therefore, the boat will have also two velocity component or not. So what is going to be? So velocity of boat along the x direction. Okay, what we are trying to calculate velocity of boat along the x direction. How much this is going to be? Tell me. Simple. How much is this going to be? Velocity of boat along the x direction. See this. We have velocity of river in the positive x direction or not. So velocity of river in the positive x direction. We have velocity of boat with respect to river sine theta in the negative x direction or not. So minus of velocity of boat with respect to river into sine theta. Got it or not? So this is the velocity of boat along the x direction. Similarly, we can calculate velocity of boat along the y direction. This is going to be how much? This is going to be how much? It is only going to be equal to. Okay. No. VBR cos theta. Why? Try to understand what is the velocity of boat with respect to river along the y direction. It is only equal to VBR cos theta. Is there any kind of velocity of river present in the y direction? The answer is no. So therefore, velocity of boat along the y direction will be only equal to velocity of boat with respect to river into cos theta. Are you able to get me or not, everyone? Radha, Nisan, Ankit,
Yes, sir.
Sneha, Afan. Is it okay, Sanjana? Okay. Okay. Now look over here. Let us move on to this point. Now, as we have calculated the velocity, now to try to understand, can we calculate the time period to cross the river or not? So, how much is the time period required to cross the river? Tell me. Is going to be how much time period to cross the river? Simple. Now look over here. To cross the river, it needs to cross this width or not? Tell me yes or no. So that means what? Time period to cross the river is going to be how much? Distance by velocity. Distance by velocity of the boat along which direction? Along the direction of y. So this is going to be how much? Distance is w divided by velocity of boat along y is how much? Velocity of boat with respect to river into cos theta. So this is the time period required to cross the river. Got it or not? Or yes or no? Are you able to get me or not? Everyone. Okay. Now look over here. Now you try to see what is going to happen. This particular person, whoever is this person, let's suppose if it does not end directly at the end point of B, what can happen? This person will end up somewhere here or not. Means this person will end up somewhere on the opposite bank, somewhere over here or not. Tell me yes or no. Is this person is going to end over here or not? Tell me, or yes or no. So now, if it ends over here, what is going to happen? It has a displacement this much or not? This displacement, yes or no? How much is this displacement? X displacement in the opposite bank. So how to calculate this X displacement? This X displacement will be how much? It will be velocity of boat along the X direction into the time period. Yes or no? Or yes or no? So what is going to be x displacement? Since there is no acceleration, so therefore x displacement will be equal to how much? Velocity of boat with respect to like velocity of boat along the x direction into multiplied by the time period to cross this river. This will be this displacement. So velocity of boat along x direction is how much? Velocity of river minus velocity of boat with respect to river into sine theta divided by what is the time period? W by velocity of boat with respect to river into cos theta. This is your x displacement. Are you able to get me or not? Or yes or no? Okay. Radha, Hitesh, Ankit, everyone clear? Yasmin, Afan, Sanjana, okay? Sneha, okay or not? Tell me yes or no. Magdumullah Khan, Magdumullah Khan, are you here? Okay. Now, as we have got all of these things, as we have derived all of these physical quantities, based upon these, we can derive two or three more quantities. Now, look over here. The question actually comes like this way. Okay, means there are some questions which comes like this kind of way. Let's suppose it is asking that find the question is like if we want to calculate, like we want to cross the river, crossing the river in shortest time. Now, like this particular boat or whatever swimmer it is, what he's trying to do, he's trying to cross this particular river in the shortest time. The question is, how is it possible? How is it possible? Can you tell me how is it possible? Anyone? Look over here. Like, see, this particular, try to understand what is the time period when you calculated over here. What is the time period to cross the river? It is equal to B by R cos theta. Cos theta. Wait 1 minute. Mhm. One biggest problem is there. Actually, one of the biggest problem is there. Okay, okay, we'll try to do it. Okay, So now look over here. So actually, do not, whatever notes I am giving you, please follow that. Do not go to look into the NCRT, and then do not go to look into the HCBOMA of this part. Okay, because both of them have done in different way. Okay. So now look over here. You try to understand. Time period to cross the particular river is how much? It is equal to T is equal to W by velocity of boat with respect to river into cos theta r naught. Tell me yes or no? Are you everyone? Yes or no? This is the time period. Now, you try to understand when this time period will be minimum. We need to cross this river in shortest time or not. So that means what? This time period should be minimum. Now, this time period will be minimum when the denominator will be maximum or not. Tell me yes or no. Now, when this denominator will be maximum, how this denominator will be maximum? Like for theta is equal to 0, we know that cos theta is going to be equal to how much? 1. After that, as the theta increases, cos theta starts to decrease. So therefore, that means what? For theta is equal to 0, I will have what kind of denominator? Maximum denominator. Yes or no? So for theta is equal to 0, what we have? Maximum denominator. So that means what? Time period is going to be minimum when when the boat follows theta is equal to 0 with respect to the width of the river. Yes or no? Now that means what? That means what? If the particular person wants to cross this river in the shortest time, what theta it should have? It should have always a theta to be equal to how much? 0 degree. If this theta is 0, that means what? Particle will start traveling along this path, along this particular path. And what will happen at that time? Its velocity, like whatever it is going to be, its time will be very much minimum. Got it or not? So that minimum time is going to be how much? That minimum time is nothing but, so minimum time required to cover the river is nothing but it is equal to width of the river divided by velocity of boat with respect to river. Okay, velocity of boat with respect to river, not just the velocity of boat, not just the river. It is equal to velocity of boat with respect to river. Got it or not? Or yes or no? Are you able to get me or not? Now, if you are aware of velocity of boat, now look over here. If you are aware of velocity of boat and if you are aware of velocity of river, what is velocity of boat with respect to river? It is going to be velocity of boat minus velocity of river. So this minimum time period is nothing but it is equal to width of the river minus velocity of boat minus velocity of river. Got it or not? Are you able to get me or not, everyone? Yes or no? Or yes or no? Okay. Now, going to the next topic. Now, what is the condition? Next condition is you want to cross the river, crossing the river on a or with shortest path. Now, logically, you just try to tell me, like if this particular person who wants to cross this river, when he will have the shortest path? Tell me, Sanjana, when he will have the shortest path? Sneha, mm-hmm. Anyone over here? Radha, when he will have the shortest path? निशान, अंकित, अंकित आवाज जा रही है ना? बताओ ना जरा, कैसे, कौन सा शॉर्टेस्ट, कैसे शॉर्टेस्ट पाथ ट्रैवल करेगा? स्ट्रेट लाइन मींस पूरा विड्थ पे अगर हम ट्रैवल करते हैं तो हमें क्या मिलेगा? शॉर्टेस्ट पाथ मिलेगा, है ना? सो इफ द पर्टिकुलर बोट travels just along this whole straight path, this is the shortest. Like if someone asks you, first I really want to understand what is happening with you guys between two parallel lines. Tell me which is the shortest path. it's this particular distance, the gap between these parallel lines are always going to be how much? They are going to be the shortest path. Yes or no? Now, if this particle follows this shortest path, what will happen? Its velocity will be perfectly equal to, like, it can cover the river or it can cross the river with the shortest path. Now, if it wants to choose this path, what should be 0? This x displacement should be equal to 0 or not. So if it wants to cover this shortest, we want to cross this river with the shortest path, what should be 0? X displacement should be equal to how much? 0. Now you know x is how much? It is equal to velocity of river minus velocity of boat with respect to river sine theta into width of the river divided by velocity of boat with respect to river into cos theta, and that is equal to how much? 0. So now if we put over here, what we will get? We will get an equation, velocity of river minus velocity of boat with respect to river into sine theta should be equal to how much? 0. From this, what we get as an equation, that at least to cover, means if the particular person wants to cross the river with the shortest part, he should have or the river should have how much velocity? That should be equal to velocity of boat into river with respect to, means velocity of river should be equal to velocity of boat into river into sine theta. Got it or not? Next thing, at least the velocity of boat with respect to the river should be how much? It should be equal to velocity of river divided by sine theta. Got it or not? Now you try to see, if this theta is 90 degree, if this theta is going to be equal to how much? 90 degree, velocity of river required will be how much? It will be maximum. Got it or not? So if this theta is 90 degree, that means what? Person is totally moving towards this path. It is never going to follow this path. So velocity of boat is going to be maximum. If this theta is going to be equal to somehow, like, if this theta is little bit finite, means 10 degree or something like 5 degree, theta can't be 0. Okay, first point is here, like, you try to understand this equation. If theta is 0, you know that sine theta is going to be how much? 0. Like 0, yes. So velocity of boat with respect to river is going to be undefined at that time. Yes or no? Velocity of boat with respect to the river is going to be how much? Undefined. So that means what? That if I try to follow perfectly this perpendicular path, I can't end up on this point B over here. Why? Because your velocity is becoming undefined. So minimum angle should be there. Minimum angle should be, means what? It should be greater than 0. Okay, means theta should be greater than 0, but it should be less than, like, whatever finite value you want to take. Okay. So that means what? At 1 degree, let's suppose if theta is also 1 degree, sine theta will be finite, and at that time velocity of boat with respect to the river is going to be maximum, and what is going to happen at that time? The particle will definitely follow this shortest path. Are you able to get me or not? So if theta is 0 only, then means, what is the condition? What is the condition this particular practical case is showing you? That you will never end up, like, if you try to move with whatever velocity you have, you will never end on this opposite bank directly if you follow theta to be 0. Okay, there will be definitely some kind of displacement towards the right or towards the left. So therefore that means what? If you follow some kind of theta to having a positive value, you might end up at the opposite bank. Got it or not? So this was the conclusion from here. Okay, so this was the neat question, that what, there was a question, if theta is equal to 0, is the particular person is going to follow the shortest path or not? So this was the question, but the answer was what? The answer was no. If theta is equal to 0, velocity of boat with respect to river become undefined, and therefore particle will never cross this river. Got it or not? And it will end up on the opposite bank B. Are you able to get me or not? Yes or no? Everyone, Nisant, Ankit, everyone, Radha, Sanjana, Sneha. Yes, ma'am. Okay. Okay. Now, this was till now, means this was whatever we can say about river and boat or swimmer problem. Next thing is rain and man problem. But to do rain and man problem, we need little bit some questions to solve on this particular topic. Okay. So today, now Hitesh is also not there, Darshan is also not there. Okay. So I have arranged the questions also, okay, based upon this particular thing. See this, I have arranged, wait, let me just show you. I have arranged, see, you have to solve this much of this kind of questions still. Like this kind of questions, I didn't have done it, okay. This question, one of the most important question we have to do. After that, this kind of questions. After that, this numericals on acceleration and gravity, which we need to do. Okay. After that, I'll go to that rain and man concept so that you can solve the things very much easily. Got it or not? So based upon this river and man, and based upon the train problems, this train problems, whatever we have done, tomorrow I'll solve at least 6 to 7 different kind of problems. Got it or not? And after that, one day more for rain and man, and after that for rain and man also 6 to 7 different kind of problem. So still, how many days are going to take? Let me just tell me. I'll tell you guys, okay, so that at least you should be perfect in this chapter. So 2 more days for this chapter, this topic. Then at least 2 more days for rain and man, and at least 3 more days for projectile motion. Okay, so 3 to the 5 to 7 minutes. At least 1 week more I will require to complete this syllabus. Correct or not? After that, laws of motion. Take into granted it is going to be more than 20 days. Okay, more than 20 plus lectures will be there. Okay, got it or not? So laws of motion will be very very good. I'm going to do in a very good way. Okay, so are you guys ready now? No problem with that, and no problem with that now. Okay, so now look over here. Okay, so based upon this, you try to solve some problems, and tomorrow I'm going to solve that rain and man, and I'm going to complete that. Okay, do not leave 1 minute. Let me just